Hey guys, welcome back to another one, and here we're going to be working on section B of mechanics of the sample 2017. And I'll be honest with you guys, I had a quick browse through this paper and done the majority of the questions up until this recording, and I could tell you instantly that this paper, at least mechanics, is probably the easiest part of the AS course. It's actually very straightforward. But anyway, let's have a go and try and break everything down. So let's have a look. So unless otherwise indicated, whenever a numerical value of g is required, take g equals 9.8. So guys, there is a clear masking on this. If you happen to use the value of g equals 10 or even g equals 9.81, you would actually lose your marks. You actually get penalized for using a wrong value g or a value that isn't 9.8. And yeah, I know it's silly, but it happens. So let's look at number 6. So a car moves along a straight horizontal road at time t equals 0, so over here, the velocity of the car is u. Okay, vectors call this line over here a. So actually, I might just do it right now. This is already solved, by the way, but I'm just going to show you just as we do it for t seconds. So from here up until t, the car travels a distance d meters during these t seconds. Now, figure 1 shows the velocity time graph for the motion of the car between this time interval, so from 0 to t. Now, using the graph, show that you can make an equation from the distance, which includes ut plus half at squared. Okay, and guys, you get no points for using any of the formulas and substituting in, because it doesn't work like that. We want to basically derive it from just looking at it. Okay, so first things first, and I've actually already solved it here. The key idea is to try and firstly give as many notations as possible. So what I did, we've already got u and t, and we drew the acceleration here. We might as well give this point here a name. This coordinate here, I just realized that this is the highest speed, so I just called it v with a capital V. Okay, just indicate that this is the speed when it reaches this point at time t. So effectively, we have 2 points. We have a coordinate here which is at a time of 0 with a speed of u. We have a coordinate here at time t with a speed of v. Now, first things first, notice 2 things. Because we want to find the distance is calculated as the area under the curve, or under the shape basically. And because this is clearly a trapezium, we can just firstly work out the area of a trapezium, and that will give us our distance. So that will be one equation. Our second equation involves acceleration. So notice how we can calculate acceleration by considering this as a gradient of a line. If you can work out the gradient from 0u to tv, then that's it. You pretty much solved it. You pretty much got the 2 components, plug them together, and you've literally proved this equation. Okay, so first things first, let's look at the trapezium. So the formula is always the sum of the 2 parallel sides. So over here, if you consider this length here, so this is u, and this length up to here is v, so I got u plus v. It's the average of those two, so that over 2 times the perpendicular side, so from 0 to t, so the distance is t. So that's why we have u plus v over 2 times t. That's easy. Now, as for the acceleration, the gradient is always calculated as the change in y over the change in x. In this case, our y is our speed, and our time is t. So change in v over change in t. Now, the change in the y coordinates is v minus u, and the change in x coordinates is t minus 0. So that's it, and all of that equals a. Now, what you want to do here is realize that the final equation does not have a capital V. So my tip is to firstly make capital V the subject of one of these formulas. I'm going to do it on the second equation because it's easier, and plug into the first equation, the d equation, and you're done. So check it out. So here's our first and second equation. So firstly, the target is eliminate v. So firstly, times t across, and make v the subject, plus u across. When you do that, sub this into the first equation. So replace v with at plus u, and it should look something like this. Collect the like terms aside, so you got 2u plus at. Expand the bracket, and you're done. And then just tidy up a bit, put a there, or 1 over 2, and we did it. That's literally the final equation. Yeah. So if you guys found this video helpful so far, I mean, give me a like and share with your friends. And of course, definitely try and make sure you subscribe as well. Otherwise, let's move on to number 7, which, by the way, is super easy too. So here we go. A car is moving along a straight horizontal road with constant acceleration. There are 3 points, A, B, and C, in that order on the road, with A, B, the first point, which I drew over here, which is 22 meters, and from B to C, which is 104. So guys, always make sure you sketch this as you go along. Makes life easy. And of course, draw the acceleration going from A to C, okay? Now, the car takes 2 seconds to travel from A to B, so I labeled it 2 seconds here, and 4 seconds from B to C. They did not give you the speeds yet, so I just called it the speed at A, which is VA, VB, and VC. Now, they want us to find the acceleration of the car, the constant acceleration A, and the speed of the car at point A. So that's really it. So essentially, I could just cross out these ones right here because we don't really need it in this question. So what do you do? So my tip is to firstly pick a suitable formula that does not have V, because if you notice, we do not have. So this is essentially can be considered an initial speed U. If you want to find the speed at A, is the initial speed. So we need a formula that has an A, an acceleration, a time, a distance, and a initial velocity, initial speed. We do not want V. Okay, so just pick the one that isn't V, and it turns out you'll find the formula to be S equals U2 plus half AT squared. Now, what you could summarize from this diagram is a couple things. We could measure from A to B, which has a distance of 22, and it takes 2 seconds. The acceleration we're trying to find, so it's a question mark, and the initial speed can be U equals VA. Now, I wouldn't use B to C because they don't want you to find the speed of B or C. They want you to find the speed of A. So you could do from A to C, which has a total distance of 126 meters, which is here, and a total time of 6 seconds. And of course, the initial speed is obviously the same because it's the same starting point, and the acceleration is of course the same because it's constant. And now all you do is plug these both into the formula here, so make 2 different equations, one for the first like I did here, when S is 22, T is 2, and the second with S is 126 and T is 6, and you get basically simultaneous equations. Now all you have to do is literally solve this simultaneously. So this is pretty much GCSE stuff now. So a quick way to do this, just multiply the first equation by 3 so you can match up the U coefficients, so we get 6 U's, and then subtract the third equation with the third equation with the second equation, and then that should eliminate the 6 U's. 18A minus 6A is 12A, 126 minus 66 is 60. Divide 12 and boom, you have your acceleration. And then plug in your A value into, well, any pair, and you should come up with a speed at point A of 6 meters per second. And that's it, done. Literally, like I said, this question was easy, and this paper is too easy. It's really damn easy. But yeah, if you guys enjoyed it again, give me a like, and otherwise I'll see you in question 8 now.